So when we last left this up, we look at building the GUI side of things here. We started off with looking at the storyboard, where we dragged buttons over, we dragged labels over, and we got our calculator to display basically what you see here on the screen. And we also did a splash page, so we did like something a little simple where we had like calculator loading in our splash page. And one thing to point out is that we have two storyboards here to look at. We have main storyboard and we have launch screen storyboard. So launch screen is essentially, as you may figure, the launch screen or the splash screen for the storyboard, and the main storyboard covers everything else. So if you put your stuff in launch screen storyboard by accident, you may have seen your app display the stuff and then go away right away. And you probably wondered what was going on there, right? Because the launch screen is only supposed to stay on for like a second or two. And we also looked at the project and how it's laid out. So we typically create folders here like nibs and view controllers and sound and images and special classes and so on. Just because as projects get bigger, you'll find that they tend to have a lot of files, and unfortunately, they don't go in alphabetical order, which is painful, right? So if you're trying to navigate like 50 to 100 files all in one place and they're not in alphabetical order, it becomes very painful to find the file you're looking for. So that's why it's better to put groups in here, and you can even put subgroups into these groups so that at least you can navigate and find your files faster. So that's why we organized our project in this way, and in the following apps that we do, we're going to do the exact same thing. So at this point, we had stopped where we finally were able to build the GUI, and what we did was we were going to continue on with the rest of the application now. So there's two sides to the coin here. We focused on one, we built the GUI, but the other side is to actually do the code that's going to support this GUI. And so that's where we're going to lead into ViewController.h. So we're going to start off by looking at ViewController.h. I'm going to get rid of this sidebar here so we have more space to work with. Now, ViewController.h and .m is the support object for that screen you saw there. So the calculator screen, those two things work hand in hand. And in our next app, we're going to look at a multi-page app where we're going to create objects and create screens and have to have them linked together so they can support each other. But for now, the home page and the view controller object that's auto-generated are automatically linked together, so we don't have to worry about manually linking them together. So what we're going to do is we're going to create the code here that's going to be operated on or executed on that calculator page that we created. So our first step is to look at ViewController.h and define the structure of this ViewController object. And we're going to have a few variables here. So we're going to start off by creating curly brackets. And if we look at the way calculators work, we have two numbers. So we might have like num1 and num2. And in this case, we'll say num1 plus num2 or num1 minus num2 or num1 times or divide by num2. But we want to define those two numbers. So we're going to say ns integer num1. We'll say ns integer num2. And with every operation, there's always an answer. So we're going to have to define an answer variable. And we'll make it of type double. We'll call it answer. And the reason we'll make it a type double is because we are dealing with division. And so division could potentially have a decimal number as a result. Whereas we are dealing with integers for num1 and num2 because, well, there's no point in defining decimal numbers there because we're not going to implement a decimal point in this example. But of course, you can take it to the next step and put in a decimal space and have decimal numbers be operated on, right? So if you decide to take this calculator a step further. So we define our three numbers. Now we have a few extra things to define here. So after answer, I'm going to define an operand because I want to keep track of whether it was a plus, minus, multiply, or divide. And there's a number of ways to do this, to define an operand. Because of the order of operations, we typically say we enter in num1, whatever it is, like 75. Then we'll say plus or minus or multiply or divide. And then we'll enter in num2, whatever number that is. Could be like 3. And then we'll hit equals. So we have to keep track of what was pressed, whether plus, minus, and so on. So there's a number of ways to do this. I could use a string to define this. I'm going to use an integer again. So I'm going to use ns integer. And I'll call it operand. And the way I'm going to work this is that I'm going to assign a number to each operation. So what I'll do up here outside of interface and below import is I'm going to define a few constants. So if you recall from C, we had this thing called pound define, right? And so pound define was a way to define a constant. So I'm going to say pound define plus, and I'm going to define plus as a 0. And I'm going to say pound define, I'm going to say minus as 1. Pound define multiply as 2. And pound define divide as 3. All right? And so I have plus, minus, multiply, and divide defined as integers, essentially. And if you recall from C, you can pound define strings as well as numbers, and you can pound define decimal numbers, and you can pound define macros or functions as well, but we won't go that direction. We're just going to use pound define to simply define some numbers for us. So if somebody presses the plus sign, we're going to set operand to plus. If somebody presses the minus sign, we're going to set operand to minus, and then somebody hit multiply, we'll set operand to multiply, and so on. So we're going to use these constant values to keep track of what operation was pressed. Okay, so that's how we're going to track the operand. And then the couple of things is to keep track of what was pressed, or what number was entered on the screen. So if somebody enters the number 75, they're going to press 7 and they're going to press 5, right? And so then the question is, how do we track what digits were pressed, and how do we keep track of the previously entered digits as well? So because string has some powerful operations where it can convert to an integer, convert to a double, and it can also join strings together, the safest bet is to use NSString to track the digits that are pressed. So we're going to say NSString, and we're going to call it the number. Right? And so for behind the scenes here, we have defined all of our variables. But we still need one more variable. And if we look back at the storyboard for a sec, I'm going to jump back here and then I'm going to jump back to the code. We have here a label that we define, and we purposely left it as the word label and not define it as 0, but this label is going to keep track of the digits that are entered as well as put in the answer, right? So that's its job. And so what we're going to do here is we're going to have to define a variable that will connect with this label. And so that way, if I update the variable, it will update the label. That's how we're going to approach this. So if I go back to ViewController.h, I need to define a label. So I'm going to say UI label, and I call it LBL text. But this isn't enough, because I can define a label, but I need to make this label visible to Interface Builder so that the GUI can connect to that label. So I have to use another keyword, a special keyword called IB outlet. So at the beginning of this line, I'm going to say IB outlet. IB outlet UI label LBL text. So anytime I have a variable that I want to link to something on the screen, I use the keyword IB outlet. Then it makes that variable visible in Interface Builder to the GUI so I can connect the GUI. And we're going to learn how to connect these things in a moment. So we have defined our variables. Now the next step is to define the getters and setters for these variables. And there's a two-step process to define these getters and setters. First, we have to define what these functions will be. So we have a special keyword called property. And then in the M file, we're going to actually implement these getters and setters using a keyword called synthesize. So we'll start off here in the header file defining these variables. So I feel that the easiest way to do this is actually take my variables and copy them. So Command C to copy. And outside of the curly bracket, but above the end keyword, I'm going to paste them using Command V. And it'll give me errors, which is fine, because it's expecting the word property. So I'm going to put the word property here. So at property for each of these. Now, for the NS integers and for the doubles, this is good enough. So any native types that I have is good enough. But for anything that has a pointer, so it has a star here, like NS string and UI label, we have to do something a little bit further. Because what's happening here is that it's actually occupying a bit more of memory than our typical natives types do. And there are some special memory operations that we have at our disposal for using certain special variables like these. So anytime there's a pointer in front of something or a star in front of that variable, we must take our property declaration a step further and define how memory is managed for those property declarations. So for property here, we're going to add in strong and non-atomic. And we'll go into a deep discussion on strong and non-atomic in a later class, but for now, what I'll say about it is that strong refers to holding on to the memory a bit longer. So retaining it for a little bit longer until we no longer need it. Non-atomic, the word atomic is an operating system term that is used for how we manage this variable. The word atomic would basically say that that variable is exclusive to a particular thread. Now, these variables may need to operate on multiple threads. So we have to make it non-atomic. We're basically saying allow these variables to work on multiple threads. So multi-threading. Now, iOS or Objective-C does have threading capability, and it's very easy to invoke and create our own threads in this project, but we're going to leave that for another course in terms of threading. But behind the scenes, there is multi-threading going on that you may not see. And you want to make these variables accessible to those other threads so it's easier to operate on. And that's why we'll always say non-atomic for our variables in this way. So these two things in the round brackets are essentially doing memory management characteristics for us. So at this point, we're done with the header file. We've defined all our variables. We've defined some constants, so plus, minus, multiply, and divide. And then we define some variables, num1, num2, answer, operand, the number, LBL text. We've invoked a special keyword IBOutlet to say make this variable available to the interface builder. And I'm going to show you right now. We're going to do a Command S first of all to save this file. And then we're going to switch back to the storyboard and we're going to join this LBL text to the label. So I'm going to bring back my sidebar there. And if I want to join that variable to a physical label, then I have to connect it or drag it. But I have to find out where that label is defined, or that label variable is defined. The first step is to go to this last option up here with this arrow. This is the connections inspector. Right now, you see that we're in the attributes inspector. And we're going to switch over to the connections inspector. So I'm going to click on that arrow, let it turn blue. And you'll see that there's a few options here. And there's empty circles, right? Now, every time I click on something, this changes and has different options depending on what's highlighted, right? This will change, okay? It changes. Now, what I want to do is I want to go to these three icons up here, and we'll go into deeper detail about these icons over the course of the apps that we get into, right? But this yellow circle has a huge meaning for us. This yellow circle is an icon that represents our ViewController object. So this yellow circle represents this class over here, ViewController.h and .m. So any variable I define that's an IBOutlet will be defined here. And if I look, I'll see LBL text over here with an empty circle at the other end. And so what I can do now is if I can join this variable to the label by simply holding down my mouse and dragging to label. And that's it. The label is now connected to the variable. Okay, I'll do it one more time. So making sure that ViewController is highlighted and making sure that my connections inspector is highlighted as well. I go to LBL text, I mouse over the empty circle, I drag to the label, and I connect it. And that's it. That's all. Now we're going to test this out. We're going to test this out in a moment by writing some code that'll join it. So we need to go back to ViewController.m, and we need to implement some code to get it going. I'm going to hide this bar here. But now for ViewController.m, our first step is to synthesize those variables. So under implementation here, we're going to synthesize all the variables we declared. So num1 or num2, num1, answer, operand, the number, and LBL text. So all the variables we define will be synthesized here. So synthesize basically saying that we're going to actually implement the getters and setters for these variables. But it'll be implemented by the compiler behind the scenes, so we don't have to worry about it. So we don't have to worry about invoking all that code and writing it ourselves. Now with LBL text and the number, it'll actually add some extra code beyond just simply setting the value. That'll manage memory depending on what we put between the round brackets. Now you notice that there's another interface definition here. This interface definition, it does the exact same thing as the interface definition in the header file. The difference is the location now. So this interface block is located here. It still serves the purpose of defining the structure of the object, but because it's inside the M file, there's really no place to you can't import an M file. So you can consider these private. Anything that's defined inside this block here is considered private because private like in Java private, because you can't import a header file. So any other file that imports your header file, your .h file, won't ever see it. Right? Anything that's defined in the header file can be seen by another object if they just simply import the header file for that object. But if it's defined here in the M file, it won't be imported. So we're going to leave this alone, and we're going to continue on to the next method here. So we have a method called viewDidLoad. Now every ViewController object will have a method called viewDidLoad. And viewDidLoad's purpose is to serve as like what I like to call the constructor for that screen. Basically, when you launch a screen, it's going to call viewDidLoad, and it's going to auto-execute any lines of code you have between those curly brackets. So basically auto runs something that you may want to run upon loading that screen. So in this case, we're going to do some initialization inside viewDidLoad. And there are some sister methods that go along with viewDidLoad. So if I start typing in, so I'll create some space down here first. So if I start typing in a new method, a void return type, and I start typing the word view, there's a few different methods that show up, few sister methods here. So viewDidAppear, viewDidDisappear, viewDidLoad is there already, viewWillAppear, and viewWillDisappear. So these all serve the same purpose. The disappear kind of tells you that when the screen is done and it's leaving the screen to go to another screen, that's when the disappear methods execute. But the will versus did, that is a timing thing, where viewDidLoad will execute at the same time, or maybe slightly after the screen has appeared. ViewWillAppear will execute at before the screen loading onto the phone. So maybe there's times where you put something in viewDidLoad, but it's just not fast enough, meaning that maybe there's some generic text and then finally your text appears on the screen, and that's not fast enough. So you might move that code to viewWillAppear, and it'll execute first for the code, and then it'll put that on the screen. So in terms of timing, sometimes things may not work right for you. You can just figure out where to place the code amongst these sister methods here. All right, so you have that available at your disposal. But we're going to stick with viewDidLoad, and we're going to initialize some values. So we had num1 and num2. We're going to set those to 0. So self set num1 to 0. Self set num2 to 0. And we'll also set the operation to plus, so self set operand, we'll just set it to plus, just to be a default value here, a go-to value. And then we'll set the answer, so self set answer to 0.0. And we'll set the text the number to also 0. So we'll say self set the number to the letter 0. Notice I'm saying the letter 0 because it's a string. So we've initialized all our values to zeros in this case. So we're doing our initialization in viewDidLoad. There may be times where you want to connect to a database, or you want to load an XML file, or get some JSON and parse it. There may be times you want to do that, and so you may want to run that in viewDidLoad, or even view will appear or whatnot. So you have your options at your disposal for auto-executing code. Now, one thing that we should note here is that with the number, the variable the number, every time we set it, because we're going to use this variable to interact with the label on the screen, we should update the label, the text of the label. So we're going to say LBL text set text to the number. And we can go ahead and run this. I'm going to use an iPhone 5S to run. I'm going to hit the play button to run. Okay, so it shows my splash screen. And it shows 0 here for the label, but my buttons still don't work. This line will get called over and over and over and over again, because every time we update a label or with a pressed digit, we're going to call this. So maybe it's not a bad idea to move this line into its own method. So I'm going to create a little method down here. Void return type. Call it print number. I'm going to move this line of code down into this method. Yeah, you can drag and drop. And just call this method where I just pulled the line from. So I'm going to say self print number. Okay. And so now we have this. We have print number, and we're calling it inside viewDidLoad. And if you run this again, it'll run exactly the same way. So we've looked at how we can connect a label and a variable together. But now our next step is to implement the buttons. So we'll start with 0 to 9 and implement those buttons. And the way we create an action for a number is to create an event handler for it. And event handlers have a special return type that basically say this is an event handler. So we're going to create an event handler here, and we'll start off with the number 9. So I'm going to say, open up my method and have a return type called IBAction. And when I start typing in IBAction for the return type, it auto-completes. You just hit enter, let it do its thing. And for selector, we're going to replace that with the name of our method. So I'm going to call it press9. And throw some opening and closing curly brackets in. Now, there is a way to simplify this down to just one method, but we're going to create press methods for each individual number, right? Because we want to get used to this idea of creating event handlers for our buttons for this exercise. So we'll just keep reinventing the wheel, even though we don't need to, right? But otherwise, we could take a special approach and figure out what button was pressed and actually attach this same event handler to all the buttons. But that's for another day. So if I want to press the number 9, then essentially I want to take the number 9 and append it to the number variable, because the purpose is I want to keep joining digits. So I'm going to say the number is equal to an opening bracket, the number, string by appending string. I'm going to join the letter 9. And notice I said the letter 9, which is grammatically incorrect. But we're treating 9 as a letter, and we're joining that to our current the number value. And every time we press a digit, we should print the number. So say self, print number. So now we've created an event handler for the number 9. Before we do it for the other numbers, let's make sure that this event handler works the way we want it to work. So we should join this event handler to the button 9. So I'm going to switch over to main storyboard, and making sure that the yellow circle is still highlighted, and making sure that my connections inspector is still highlighted in blue. If I look at the bottom of the list, I should see press 9, the method press 9 that we just created, with an empty circle. If I mouse over, it turns into a plus. So if I drag that circle to the button number 9, I'll have a list come up. And this list represents the different possible operations that could happen where I would execute this event handler. And I want to pick the one relevant to the button. So I look down the list, and touch up inside makes the most sense. So touch up inside essentially says that I'm going to press down the button, but when I let go of the button to execute the event handler. So I'm going to choose touch up inside. And for consistency in this course, we're going to use touch up inside all the time. Run this and see what happens when you press number 9. All right, so it's loading. Press 9 over and over again, and look what happens. But if I press 8, press 7, so you're noticing that there's a 0 in front still. And that's because we really should have a way to get rid of that 0, like a typical calculator would. And that may involve an extra if statement on our part, but for time's sake, we'll let it be. We could enhance the calculator to do that, but we'll let it be. But the idea is that our 9s work. We keep pressing 9, and it keeps adding it to the current number. Right? That's our goal. Now the next goal is to get 8, 7, 6 down to 0 working as well. Okay? So at this point, you should have 9 working, and you should be able to add digits, number 9, to your current number. So the next step then is to go back to the M file and do the same thing for the other digits. And it's easier just to copy and paste. So we're going to have the exact same methods, which I know is reinventing the wheel. Right? And then just basically change press 9 to press 8, press 7, press 6, but don't forget to update the string by appending string call as well. So we're going to change this to press 8. Press 7. And 0. Okay, so we should have 0 to 9 event handlers ready to go. So once you have all the event handlers done up, then the next step is to connect them. So we'll go over to main.storyboard, and we'll connect all the event handlers together. So now you should see, assuming that you have the yellow circle highlighted again, and you have the connections inspector highlighted again, you should see press 0 to press 8 as well as press 9. And then you just start dragging and joining them to its respective numbers. Okay, and go ahead and give it a run again. Okay. All right, so if we press any of the numbers like 9, 5, 3, 4, 2, 7, it just keeps joining those particular numbers over. Right? So at this point, we have our digits operational, and we're able to enter a number into the calculator. The next step then is to look at our operands. We have plus, minus, multiply, divide. We also have clear as well. We also have clear that we have to implement, and equals we have to implement as well. And so we'll start off with plus, minus, multiply, and divide and implement those methods right now. So if we look back at ViewController.m, the first thing we need to look at is what happens when we're done entering our number. When we're done entering our number, we should save that number. So we should create a method called save num1. So I'm going to move up here. So at this point, we want to create an operation that will handle pressing on plus, minus, multiply, and divide, and then also saving that number. So we're going to create a method to save the number. We'll call it void return type save num1. And within save num1, all we're going to do is take that number that was pressed, convert it to an int, and save it inside num1. So we're going to say num1 is equal to the number integer value. So this is going to take a string, convert it to an int, and we're saving inside an int called num1. Now that we have saved the number, we need to reset the number to the letter 0. So we're going to say the number is equal to the letter 0. And then we're going to, anytime we update the number, we got to update the label. So we're going to say self print number. All right, so now this is saving that first number that was entered. Okay, this is saving that first number that was entered. Okay. The next step then is to create event handlers to do the plus, minus, multiply, and divide. Okay, so that's our next step. We know how to save the number now. We need to just create the event handlers for plus, minus, multiply, and divide. So we're going to create an event handler, IB action return type. I'm going to call this one set plus. And we'll start off by just doing the plus here. If somebody was to press the plus button, it means that they're finished entering the first number. So we should call save num1. So self save num1. So that's going to save the number for us. The next step then is to set the operand to plus. So we're going to say operand equals plus. And that's it for the plus right now. That's all we need to do. We've saved the number. We've set our operand to plus. And we're going to do the same thing with minus, multiply, and divide. So we're going to create 3 more event handlers to do this. So we're going to say IB action set minus. We'll do the same thing. We'll say self save num1. And operand equals minus. Do the same thing for multiply. So IB action set multiply. And we'll we'll say self save num1 and operand equals multiply. And finally for divide, we're going to say, again, self save num1 operand equals divide. Okay, so at this point, let's take our event handlers and let's join them, so we don't forget. So go back to main storyboard. We should see these other event handlers down here at the bottom. Set divide, we'll join that to our divide button. Set minus to our minus button. Multiply, our multiply button. And plus to our plus button. At this point we could run this, but anything we do really won't make sense. You won't see much other than the number resetting to 0. So what we'll do is we'll continue on with trying to finish off this equal sign here. So we'll switch back to ViewController.m. So we'll start off with the equal sign and say IB action and call it calculate. At this point, the user would have entered in a second digit before hitting the calculate button. If not, the number's 0, so it would have just taken 0 anyway. But our first step now is to save the current number as num2. So we're going to say num2 is equal to the number integer value. So we're saving num2. At this point, we can do our calculation. At this point, we can do our calculation. So we're going to do an if statement, essentially. We're going to say if the operand is plus, then answer is equal to num1 plus num2. Else if for minus, answer is equal to num1 minus num2. Else if multiply, num1 times num2. Else. We can do an else if, but at this point, you know it's a divide. And we'll just say num1, answer is equal to num1 divided by num2. At this point, we're done the calculation. We have some housekeeping to do. We have some housekeeping to do. So what we're going to do is we're going to clear up everything we have. First by printing to the screen. So we're going to say the number is equal to ns string with format. And we're going to basically convert this answer from a float into a string. So we're using string with format to do so. So what's happening here is that we're generating a string here that is just going to simply have a %f, or a float, or a double in this case. That float or double will be answer, and we'll save it as the number. The number is always our go-to for printing out something to the screen. So our next step is to print the number. So we'll say self print number. And then we'll reset our values. We'll say num1 equals 0, num2 equals 0. We'll say answer equals 0.0, just to do some housekeeping. Now, this calculate method isn't completely done because there's a couple of issues with it. But what we're going to do is we're going to execute this and discover these issues along the way and fix them along the way. So there will be issues that come up, and you may try and take a guess at where those issues may lie, because add, subtract, and multiply are pretty straightforward. It's division that's going to cause us some trouble here. But let's connect it and let's go ahead and give this a run. So we'll go back to main storyboard, and we should see a method here called calculate, and we'll join that to our equal sign. And now we can go ahead and give it a run. So at this point, we could do any operation we want. We do like 9. We can do like 9 plus 8 equals 17. But now, if I say 5, it keeps joining it. So we've got a problem here. So I can't do a second calculation here. Right? It does some really weird things here. And this isn't even the right answer here. So what we need to do is we need to do some more housekeeping to this. So we'll go back to ViewController.m. And we're going to add a method to clear the value. So this will be a very lame calculator where it doesn't automatically clear everything when we're done. So we need to work on that. What we're going to do here is we're going to create a method. Just put it over here. It's also an event handler. So we'll put it down here. And we'll call this, it'll be an IB action, clear num. And we'll do the number is equal to 0. And we'll do a print number again. Okay. And we'll join this clear num to that clear button. And this will allow us to do operation and operation and operation, but we have to clear it every time we're done. A lame calculator, yes, because a real calculator would actually take care of that for us, but nonetheless, it gives us a way to clear this up. So go back to main storyboard. We'll join clear num to the letter C. We'll do that. And now we'll run it one more time. Okay. And so now if I do 9 plus 8 is equal to 17, I have to do a clear now. If I do a 5 minus 4 equals 1, I do a clear. 3 times 4 is 12. Do a clear. And 7 divided by 8 is that. So this is our first issue. So remember what I was saying with division, it's there, but it's not perfect yet? Well, that's because we have to look at what happened here. So we said 7 divided by 8. It should be 0 decimal something something something. But when we look back at how we defined 7 and 8, we defined num1 and num2 as ints, and our answer is double. So an int divided by an int, it still thinks is an int. So that's why it ends up being 0. So we have to cast those to doubles. So if we go back to our calculation, we'll do a double for each. Right? So answer equals num1 divided by num2, but each doubled. It's only for division. Yeah. Yeah. If we run this again, and if I say 7 divided by 8 is equal to 0.875. So now we can do division, but, and there's a but, what if I said 7 divided by 0? Yeah. Luckily for us, it just says INF, infinity. But it should have done an app crash at that point. Older versions of iOS may have crashed with a bad access error, but here we're lucky it actually is accounting for it. But we should account for this. We should do something about this. Yeah. We should fix this up. So, what we need to do is test to see if num2 is 0. So in this else statement, we're going to do an if num2 equals 0, then we'll do something, which I'll get into in a sec. Otherwise, if it's not 0, we'll do our calculation. So we should have some sort of error message here. We could have that in the form of a pop-up alert, or we could just simply have the label say error. Right? There's two approaches to this. We're going to start off with the old way of doing things, and then eventually we'll get into a more newer way to define an alert box. So we're going to still define an alert box either way. What we're going to do here is we're going to use an object called UI alert view. We're going to say UI alert view, and I call it alert is equal to UI alert view alloc, and I'll put on a new line here. Init with title. So you're seeing a new init method here. And the way this works is there's a number of different arguments for this method call. All right? So our first one says init with title. We have to put a title here. So I'm just going to say error. The second argument is a message. I'll put a message that says divide by 0 or cannot divide by 0. The third argument, delegate, we're just going to say self for it. We'll get more into delegates in a future discussion. Cancel. Now the last two arguments are cancel button title and other button titles. This argument, or this alert, is going to have just one button. It's going to say OK. So our cancel button title will be OK. And other button titles is going to be nil. If there were more buttons, like if this was like a yes, no, maybe type thing, then our first button would be no, and our second ones would be yes and maybe. And we would just outline a list of buttons in this last argument here. Right? And so then once we define this alert pop-up object, we're just going to say alert show. And now that's it. This should handle divide by 0. Now you'll notice that there's a warning here, which says UI alert view is deprecated. It was deprecated in an earlier version of iOS. And what we're going to do is we're going to discuss later how we will fix this to be something for the newest iOS, how they've changed it and how we're going to adapt for it. But for now, we can run alert view, and it should run perfectly fine. So now if I say 7 divided by 0, it gives me a pop-up error. It says error, cannot divide by 0. Okay, if I do like a 9 divided by 0 equals, gives me an error message, cannot divide by 0.